नमस्कार बच्चों। आज हम लोग ग्रेड 11 केमिस्ट्री का फर्स्ट लेसन सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री का पास्ट पेपर क्वेश्चंस देखने वाले हैं। सम JEE एंड नीट पास्ट पेपर क्वेश्चंस। ओके, सो as I show the slides, please take the screenshot. Okay, so we start with the first question. So the first question is, they have given you some molecules, 5 of them: sodium carbonate, sodium oxide, okay, sodium hydroxide, hydrogen and carbon dioxide. All these are molecules. They have given you the masses and also the molar masses. Now they have given you the molecules, and from there you have to tell which among the following has equal number of atoms. Okay, so by giving the molecules, they have asked you which of them has equal number of atoms. Okay, so I hope you have taken the screenshot. Now students, in order to find the number of atoms, okay, or the number of particles, we have the formula atoms equal to our total number of moles times Avogadro number. Na stands for Avogadro number. You know the value of Avogadro number. So I'll just keep it as it is because I have to use the Avogadro number in all of them. So I'll just keep it as it is. And because they have asked you the total number of atoms, I also have to divide with the number of atoms in each molecule, which is called as atomicity. They have given you the molecule here. For example, the first one, sodium carbonate. Atomicity means the number of atoms. Like for example, there are 2 sodium atoms, 1 carbon atom and 3 oxygen atom. This is called as atomicity. So the total is how much? 6. Why I'm multiplying with atomicity? Because they have given you the molecules. And you have to find the number of atoms. Okay. For the first molecule, that is sodium carbonate, the mass is given to you. This is 212, and the molar mass is 106. That's how you find the number of moles, right? Mass over molar mass times Na. I'm keeping it as it is. I'll tell you why. And atomicity, 2 sodium atom plus 1 carbon and 3 oxygen atom. That comes to 6. Atomicity is just the number of atoms present in the molecule, and this comes to 12 Na. Okay, so you don't have to multiply now with the Avogadro number. Okay, it's easy to compare like that. Next one is Na2O. Okay, and here the mass given is 248 over 62 is the molar mass. It's already mentioned in the question, times Avogadro number times 2 sodium and 1 oxygen. That gives 3. So this is 12 Na again. Okay, so these two compounds have the same number of atoms, but we have to find the rest of also. So third one is sodium hydroxide. The mass mentioned is 240 over molar mass is 40, that's given in the question, times Na times how many atoms are there? Sodium is 1 atom, oxygen is 1 atom, and hydrogen is 1 atom. That gives 3 atoms. So this is 18 Na. Okay, so for now, sodium carbonate and sodium oxide have equal number of atoms. Okay, so I'm rubbing sodium hydroxide because we don't have sodium hydroxide will not come in this option. Okay, so the fourth one is third one we finish. I'm keeping first and the second one because they have the same number of atoms. The next one is hydrogen. Okay, Hydrogen, the mass mentioned is 12. Molar mass is 2. Molar mass is 1 actually, but there are 2 hydrogen atoms. So that's why 2 plus Na plus how many hydrogen atoms are there? 2. That comes to 12 Na. So this also is our option. So sodium carbonate, sodium oxide and hydrogen have equal number of atoms. But we have still one more option to check, which is our carbon dioxide. Carbon dioxide, the mass mentioned is 220 over molar mass is 44 times how many atoms are there? 2 oxygen and 1 carbon. That means 3 times Na, sorry. And this comes to 15 Na. So we cannot take this option. So 1, 2 and 4 is our answer. So that means the compounds that have equal number, or the molecules that have equal number of atoms is sodium carbonate, sodium oxide and hydrogen. Okay, so I just kept the Avogadro number as it is because we just have to, so this is our answer. Okay, so I hope this is okay. And molar mass, just when you solve the molar mass of, just to note down, molar mass of sodium is 23. Here the molar mass I didn't mention because it's already, students, here the molar mass is already given to you, that so that saves a lot of time for you. So this is your answer. Okay, now students, question number 2. They have given you the, I hope you have taken the screenshot. They have given you the molarity. It is 1 by 20 is the molarity. And they have mentioned the molar mass of glucose. It is 180 mm molar mass. It is 180. And they have given the volume in milliliters. And from there you need to find the mass. So students, molarity, what is the formula for molarity? Molarity is moles by volume. Volume should be in liters, right? So molarity is 1 by 20. And how do you find the moles? Mass over molar mass, right? So I'll write it as it is. Mass over molar mass is mentioned 180 in the question itself. Volume is 250, but they have mentioned is in milliliters. So I have to make it into liters. So divided by 1000. So when you solve this, mass comes to 2.25 grams. So this was a fill-up type of a question. Okay. So this is how you solve. So that's why you have to memorize all the formulas. Okay, you have to memorize all the formulas. So these are the 2 questions that we solved. Now, students, I'm sharing the screen for the next set of questions. 4 questions here. Please take a screenshot. Okay, and here the third question they have mentioned is about 1 gram of hydrogen. So they have given you the mass of hydrogen, 1 gram hydrogen, right? Has same number of molecules. So hydrogen is a molecule here because H2, 2 atoms make 1 molecule. 1 gram of hydrogen has same number of molecules as in. So there are 4 options there. You need to choose which of them. So 1 gram of hydrogen has certain number of molecules, right? So let's find that first and which is matching with the rest of it. Okay. So So 1 gram hydrogen has how many molecules. So here they have not asked anything about the atoms. So we will just directly use the formula. So number of molecules is equal to moles time Avogadro number. Here also I'll keep it as it is. Avogadro number as Na. Okay. So let's first find out how many number of molecules as hydrogen has. So hydrogen has, how do you find the moles? Hydrogen is, molar mass is 1, but there are 2 atoms, so we need to multiply with 2. So moles is what? Mass over molar mass. Okay. So this is the number of molecules for hydrogen. So let's find out for the rest of it. Okay. So the first one, A, is nitrogen. Okay. So I'll just mention the atomic masses. Nitrogen is 14, carbon is 12, oxygen is 16. Okay. Hydrogen is 1. Okay. Now, they have mentioned the mass of nitrogen as 14 over what is the molar mass of nitrogen? It's 14, but we have 2 atoms, so 28. So this is the moles times Na. So which comes to 1 by 2 Na. So is it matching with hydrogen? It's matching with hydrogen. So this is one of our answer, but we have to check if we have anything else extra. B is water. Finding the moles of water, the mass given is 18 over 2 hydrogen plus 16 oxygen. That comes to 18. I'm writing it directly because by now you know how to find the moles times Na. So this comes to 1 Na. Okay. Now, the third one, so this is not our answer. 1 Na is not our answer. C, question number C. So we got one option as A, so we are checking for the rest of it. Okay. C is carbon monoxide, CO, and the mass mentioned in the question is 16 over, carbon is 12, oxygen is 16. Okay. Now, carbon is 12, oxygen is 16. So that comes to how much? That comes to 28. So this is 0.57 Na times Na. This is 0.57 Na. So this is also not our answer. So I'm just rubbing off the wrong answers for now. So B and C is not our answer. A is our answer until now, but we have to check one more, the D option, which is the D option. It is 28 grams of nitrogen. 28 grams over. The molar mass is 14 times 2 times Na. Okay, so this is also 1 Na. So this is also not our answer. So we will go with our A option. Nitrogen has the same number of molecule as hydrogen. Okay, so this is our answer. A option is our answer. All right. Okay, students. Before we go to the next question, I'll just share the screen so that you can have a look at the question. Question number 5. Okay. We did question 4 now. So let's do question number. Before I move on to the solving the question, I just wanted to check question number 4. Okay, read the question carefully. So in question number 4, what fraction of iron, fourth, okay, what fraction of iron, Fe means iron, exists as Fe3, okay, in Fe 0.96O, okay, and consider that Fe 0.96O be made up of iron 2 and iron 3. Okay, so they have asked you the fraction of Fe3 plus. Okay, now over here, students, these are the informations that they have given. Okay, so you have to find the fraction of Fe3 in this particular compound, iron oxide, and this iron is made up of Fe2 and Fe3. Okay, and Fe 0.96 is the total amount of iron that's present. Okay, and this Fe is made up of Fe2 and Fe3, and this 2 and 3 refers to the charges. Okay, valencies, you will learn in grade 12 about the some elements have more than one valencies, or okay, more than one charges. So iron is one of them. Okay, so that's what we for now we will assume that so for now total amount of iron present is 0.96 in this particular compound. Okay, now Fe2, let the amount of Fe2 be X. Okay, if the total amount is 0.96, then what will be Fe3? It will be 0.96 minus X. So Fe 0.96 is made up of iron 2 and iron 3. So if iron 2 is X and the total amount of iron is 0.96, then Fe3 is 0.96 minus 0.96 minus X. Okay. Fe3 is 0.96 minus X. Okay. Now, oxygen has a charge of -2. Okay, this also you will learn in when you are in grade 11 itself. You will learn oxygen has a charge of -2. Okay. Now, in a compound, whenever a compound is formed, suppose iron and oxygen. Iron is a metal, it has positive charge, and oxygen is a non-metal, it has a negative charge. But when a compound is formed, it is neutral. Okay, equal and opposite charge, they neutralize each other. Okay, so we will assume this, and we will write in this manner: the charge of iron is equal and opposite to that of oxygen. In that way we will solve. Okay, now iron 2 has a charge of 2 and amount is X, right? There is one more iron present, iron 3, the amount is 0.96 minus X. This is the positive part, the metal part. It is equal to oxygen. And how many oxygen atoms are there? 1. The amount is 1. So we will consider only the magnitude, not the sign. Okay. So that means I have taken iron 2. It has X amount. Iron 3, it has 0.96 minus X. It is equal to the oxygen, charge of oxygen. Okay. Now, when we solve this, it comes to 2x plus 2.88 minus 3x is equal to 2. And x, when you solve, it comes to 0.88. Okay. So that means iron 2 is x, right? Iron 2 is x. So iron 2 is 0.88. So how much is iron 3? So I'll write it over here. If iron 2 is 0.88, how much is iron 3? Iron 3 is 0.96 minus 0.88, which comes to 0.08. Now this is not our question. We have to find the fraction of iron 3. Okay, how do we find a fraction? How do you find a fraction? Fraction is the amount of iron present, iron 3 present in this case because they have asked for iron 3, by the total amount of iron present in that compound. So how much of iron 3 is present? By how much of iron total amount we took? 0.96. It's given in the question. So it comes to 1 by 12. This is our answer. So the fraction is 1 by 12. You must have seen this in the option if you have taken the screenshot. Okay. So this is our answer. So this type of question is also one of the common questions. Okay. I hope the next question you have taken the screenshot. Here they have asked you one molal solution contains 5 moles of the solute. Okay, so you have to find the volume. Okay, so molality, you know already the formula. Molality is given by number of moles by volume of the solvent in kg. Okay, so molality is 1. Okay, number of moles they have given you directly, so it's easy, by volume in kg. So the volume in kg is 0.5. Okay, so it's a fill-up question. This is kg. If in the options they have asked for grams, this you have to multiply with 1000. In case they have asked for answer in grams. Okay, so this is how you find out. This was the basic direct application of the formula. Okay, now the next question. If you see question number 6. Question number 6. 1 gram of sodium hydroxide. 1 gram of sodium hydroxide was treated with 25 ml 0.75 molar, okay, HCl. And you have to find the amount of unreacted NaOH. This is the question. Okay, so I've just written down the contents of the question. 1 gram of NaOH is treated with HCl. So this is a acid and base reaction. It is a neutralization reaction to give you salt and water. Okay, it's already balanced. Okay, now here unreacted NaOH. Okay, so unreacted NaOH means HCl would have been used up. But let's check by using limiting reagent, which is our limiting reagent. So that means that limiting reagent is used up completely. So that's why maybe the NaOH is left unreacted. But we have to check. Okay, so in order to find the limiting reagent, what is the first step that we do? Our first step is to find the number of moles, right? Here the mass of NaOH is given. So 1 over sodium is 23, oxygen is 16, hydrogen is 1. So sodium hydroxide comes to 40. This comes to 0.025. This is our number of moles. Okay. For HCl, we can find directly because molarity times volume will give you the molarity times molarity times volume in liters will give you the moles directly. So molarity is mentioned, volume is given, but you have to make it into liters. So 25 by 1000 times 0.75. That comes to 0.0187. Okay, so 18. Okay, so this is our number of moles. What is the next step to find the limiting reagent? We divide by the balancing number. But here both the balancing numbers are 1. So we take the same numbers. So which one is less in amount? HCl. So as expected, HCl is our limiting reagent. Okay. So let's check out how much of moles of NaOH has reacted. Okay. Because if we find the amount that has reacted, we can subtract it from the total amount, right? So number of moles of reacted NaOH. Okay, so this is NaOH, this is HCl. So balancing number, 1 mole reacts with 1 mole of HCl. So how many moles react with 0.0187, our limiting reagent 187? So X comes to 0.0187. Okay, now this is the moles. So what is the mass of reacted NaOH? What is the mass of reacted NaOH? Mass is what? Moles time molecular mass. How to find the mass? Mole time molecular mass, right? So I'll just rub this part. So mass of NaOH, reacted NaOH is equal to how many moles are there? We found out reacted 187 times 40. We already found out the molar mass of NaOH 40. I gave the mass numbers, right? Masses times 40. It comes to 0.75 grams. This is for the reacted one. So definitely we have the total mass given. What is the total mass that's given? Total mass is 1 gram, right? So unreacted NaOH is equal to 1 minus 0.75, which is equal to what? 0.25 grams. So this is our answer. So by using limiting reagent, we found out the how much of NaOH has reacted, and from the reacted one, we subtracted the total mass minus the reacted NaOH. That will give you the unreacted NaOH according to the question. Okay. So we finished. So here they have given in mg, right? So we got in grams. So we got in grams. So we just have to multiply with what? 1000. Okay. When we multiply with 1000, we get what? 250 mg. Okay. So our answer in this case is B. right? Our answer is B. So, coming to the next set of questions, question number 7, right? If you see question number 7, they have asked you for the empirical formula, okay? They have given you some percentages. An organic compound contains 78% of carbon and the remaining percentage is hydrogen. They have also given you the molar masses or of the atomic weights of different different elements. Okay. Now, empirical formula. You have to here I'm not. They have given the options. Okay, but I have given as a fill-up question. Okay. Now, I hope you remember the steps for the empirical formula, right? So, I just share the screen. So according to the question, there is 78% carbon and rest is hydrogen. If the mass is given in percentages, there is 78% carbon, rest is hydrogen means 100 minus 78. Okay, 100 minus 78, that comes to what? 22%. So what is the first step to find the empirical formula? Find the number of moles. Okay, so for moles, what do? You divide by molar mass or atomic masses because it's an element. So carbon is, it's mentioned in the question 12, hydrogen is 1. So this is dividing, we are dividing this by 12 and 22 by 1. So we get what? We get so we divide each of the elements with their molar masses to get the number of moles. So in the first case, when we divide, we get 6.5. Over here it is, so I'm writing it here, 22. Okay, what is the next step? Divide by the least number of moles. Okay, so which is the least number here? 6.5. So we divide both of them by 6.5. So we get 1 here and we get 3.38. Now students, here after the decimal, 3.38. Now students, here after the decimal, we are getting 3, that is less than 5. Okay, so we can ignore this and keep it as a whole number because number of atoms cannot be in whole fraction. Okay, empirical formula is the ratio of the simplest whole number ratio of the number of atoms. So the ratio is 1:3. Ratio is 1:3. So how do we write the formula? Carbon, how many atoms are there? 1. Hydrogen, how many atoms are there? 3. Okay, so this was one of the options there. And why we don't take decimal places? Because number of atoms cannot be fractions. Okay, because empirical formula is the simplest whole number ratio of the atoms present in the molecule. And we can ignore this one and we can write it as CH3. So this is our empirical formula. Okay. So this was direct simple question. Now coming to the next question, question number 8. In question number 8, it's the production of ammonia by something called Haber's process. So don't worry about the name of the process. You will be learning about it. Okay. So the number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's process. Okay. So you will be learning later that Haber's process is hydrogen. They have mentioned 20 moles of ammonia is given in the question, and H3 is ammonia. Okay, this is mentioned in the question. In Haber's process, you will learn hydrogen reacts with nitrogen to give you NH3. This you will learn later, okay? And balancing the equation, okay? They have asked you how many moles of hydrogen is needed, okay, to produce 20 moles of ammonia. So they have asked about hydrogen and they have given the information about ammonia. So we take these two variables, okay. So we don't have the amount of hydrogen or anything like that. So they have just asked for the number of moles. So we go with the balancing number, stoichiometric equation. So balancing number here is 3 moles. 3 moles of nitrogen reacts with how many moles of ammonia? 3 moles of hydrogen reacts with nitrogen to give you how many moles of ammonia? 2 moles of ammonia. You have to find the number of moles of hydrogen to produce how many moles of ammonia? 20 moles. It's mentioned in the question. I'm not talking about nitrogen because they have not asked you anything about nitrogen, neither they have given you any information about nitrogen. So we don't need nitrogen now. So I'm cross multiplying it, and when you solve x, it comes to what? X comes to 30 moles. So this is our answer. Okay, so this is how you use stoichiometric equation. Okay, from the information given and asked. Okay. Coming to the next question. This is again a question on empirical formula. A lot of questions from empirical formula in JEE and NEET is asked. Okay. At least one question you will definitely find. Here, question number 9 is, they have asked you, they have given you the percentages of carbon, chlorine and hydrogen. Okay. So carbon is 14.5. Chlorine is 64.46. Hydrogen is 1.8%. Okay. And when you add the percentages, first you need to check whether it comes to 100 or not. So when I add them, it is not coming to 100. So definitely there is one more element. Definitely it will be oxygen. Okay. So how I can find the amount of oxygen or the percentage of oxygen? You add up all of them, 14.5 plus 64.46 plus 1.8. Okay, add up and you subtract from 100 because every compound is 100%. We assume like that. So when you subtract, it comes to 19.24. Okay, so percentage is 19.24. So this is how you find out the unknown. If it comes to 100, well and good, but if it's not 100, you have that means there's one more element. Okay, I hope it's clear till now. Okay, now what is the first step to find the empirical formula? Divide by the number of the mass numbers to find the number of moles, or rather finding the number of moles. The atomic mass is 12. It's mentioned in the question. Chlorine is 35.5. Hydrogen is 1 and oxygen is 16. Okay. The answer here is 1.2. 1.2. What is the next step? Divide by Least moles. Least moles. Which one is least? Clearly it is 1.2. When you divide, you get this as 1, 1. But here you're getting 1.5 and 1.5. Now see, students. Here it is, if after the decimal, if it comes to 5 or above, okay, we cannot just round it off. We have to multiply with a certain number that will make it into a whole number. Okay, so as I told you, number of atoms cannot be fraction. Okay, so until this part, I'm just rubbing. Just keep the atoms here: carbon, chlorine, hydrogen, and oxygen. Okay, so because it is 5 or above, we have to multiply with a number that will make it into a whole number. So we start with less numbers like 2. If I multiply with 2, can I get 3 over here? Here also I will get a 3. So that so I can follow that method. Okay. So sometimes multiplying with 4 will make it a whole number. Okay. So depending on the number. So here I have to multiply all of them with 2. Okay. So 2, this is 3, this is 3, and this is 2. All of them. So if you multiply all of them, no issues. Okay. So it's, after all, it's a ratio, right? So sometimes what happens when you multiply with 2, nothing happens. It still remains decimal. You have to multiply with 4, then it comes as a whole number. Okay. So how many carbon atoms are there? 2. How many chlorine atoms are there? 3. Hydrogen is 3. Oxygen is 2. This is your empirical formula. Okay. So this is how you do it. Now, question number 10. This type of questions we have already done before during the lessons. Okay, in this, molarity of 70% mass by mass. So in the class, we did it as weight by weight percentage. So instead, I told you there also, they can write as mass by mass percentage also. Okay, so this is 70%. You know what it means. 70 grams of solute in 100 grams of the solution. Okay. The density is given as, density rho is given by 1.25 grams per ml. Okay, so this is the information given. Now, I'll just share the screen. You have to find the molarity. So molarity, you know the formula, but we have to gather some information. So this is the information given. The 70% mass by mass or weight by weight means 70 grams of the acid in mass. So in 100 gram of solution. For molarity, we have moles over volume in liters, right? So in order to find the volume, density is given, mass is given. So how do you find the volume? Volume is what? Mass over density. We have both the information with us, right? So we have mass equal to how much? 100 grams by density rho is 1.25 grams per ml. So what will be the answer over here? It is 80 ml. Okay, it is 80 ml, but we want it in liters. Okay, now over here, in the question itself, they have given you the, so this is the volume. So I'll just rub this part. Volume is 80. Volume is 80 ml. Okay, in the question itself, they have mentioned the molar mass of acid. Molar mass of acid, it is equal to 70. So that solves our problem also. So how to find the moles? Mass of acid by molar mass. Yes? So how to find the moles? Mass in grams over molar mass is mentioned in the question itself. Over. Volume is 80. How to make it into liters? Divided by 1000. Okay. So when you solve it, it comes to 12.5 M. Capital M is the unit for molarity. Okay. So this type of questions we have already solved. Yes. Okay, students, we finish with the 10th one. Okay, coming to the 11th one. In fact, this type also we discussed during the lesson. Okay, concentrated nitric acid is labeled 75% by mass. Mass by mass or weight by weight. Okay, the volume in milliliters of the solution which contain 30 gram of nitric acid. Okay, and the density of the solution is mentioned rho 1.25 grams per ml. Okay, so these are the information that's given, and you need to find the volume of the solution that contains 30 grams of the solute. Okay, so these are the informations that's given. Okay, so rho is 1.25 grams by ml. Okay, now 75% mass means 75 grams of nitric acid, that is HNO3 is nitric acid, in 100 grams of solution. We did this in the previous sum also, right? So if I take nitric acid, that's the solute, and I take the solution. Okay. Now, sorry, it's not 7 grams, it is 75 grams. That's the question, right? 75%. So 75 grams. 75 grams. Okay. So 75 grams is there in 100 grams of the solution, right? So in order to make 30 grams, how much of nitric acid or how much grams of solution does it make? So when we add 75 grams of nitric acid, it makes 100 grams of the solution. So if we use 30 grams of nitric acid, how much solution does it make? That's the question. I hope the question is clear. So when we cross multiply, we get X equal to 40 grams. This is so when we use 30 grams of nitric acid, we get 40 grams of solution. Okay, so I'm writing it here. So when we cross multiply, equal to 100 times so students, in order to do the calculation, I'll just drop this part. Okay, this part. So when we do the calculation, 75 times X is equal to 30 times 100. So X equal to what? X is equal to 40 grams. So when we use 75 grams of HNO3, we get 100 grams of solution. So when we are using 30 grams of nitric acid, how much of solution we are getting? We are getting 40 grams of solution. But the question is not in grams. We have to find the volume of the solution. So how to find the volume of the solution? They have given you the density, right? Volume is equal to mass by density, which is equal to mass is 40 grams. So I'm rubbing this part. So students, mass is 40 grams by density is how much? It's given in the question, 1.25 grams per ml. So when we solve this, it comes to 32 ml. Okay. So students, this is how we solve the question. Okay. So sharing the screen again. Coming to the 12th question. It's again a question based on empirical and molecular formula, and see how many questions are coming from empirical and molecular formula. Here they have asked a molecular formula. Okay. So in the previous questions, they were just asking the empirical formula. So this is a different type. Okay. Though we have done this type. In this, they have given the percentage of carbon is 54.2. Hydrogen is 9.2. Oxygen is 36.6. So whenever they give percentages, it is best to add up the percentages, so whether it comes to 100 or not. Yes, so it comes to 100. And in the choices also, they have not given any other element. So that's another way of confirming. Well, so and also they have given another information. The molar mass is 32. They have given 132 grams per mole. It's mentioned in the question. Okay, and the atomic masses they have given. So first we have to find the empirical formula. Okay, then we have to use the relation between empirical formula and molecular formula. Okay, so here they have mentioned the molar mass, which is equal to 132. Okay, it's mentioned in the question. Okay. Okay, now what is the first step? You find the number of moles by dividing by the mass. This is 12, hydrogen is 1, oxygen is 16. It's mentioned in the question, you would have seen, right? So this comes to 4.5, this comes to 9.2, and this comes to 2.28. Then what's the next step? Divide by the least mole. Which is the least mole? 2.28. All of them by the least number of moles. Right. So this comes to 1, this comes to 2, and this comes to 4. So we got our empirical formula EF. Equal to C2H4O. This is our empirical formula. Okay. Now we don't need this calculation now. So I'm just rubbing it off. We got our empirical formula. Now they have given you some information about molecular mass, which is equal to 132. 132. It's mentioned in the question itself. And you got the EF. I'll write it here. Empirical formula is 132. Now, you have a relationship between empirical formula and molecular formula mass. Okay. Empirical formula mass times N is equal to molecular mass, molar mass. Molar mass, you already know, it's mentioned in the question. N you need to find out times. How do you find the empirical formula mass? Same, just as you find the molar mass of molecular formula, you are finding the mass of the empirical formula. So, carbon is 12, 12 times 2 because there are 2 carbon atoms, plus 4 times 1 plus 16. Okay, so you are finding the mass of the empirical formula, which is equal to, writing it here, how many carbon atoms are there? 2 times, what is the mass? 12 plus 4 times 1 plus 16. That comes to 4 plus 16. That comes to 44. So you are, just as you calculate the molar mass, similarly you find the mass of the empirical formula. You just add up the mass numbers considering the number of atoms. So empirical formula mass is 44. So N value you will get it as 132 by 44 equal to 3. Now there is another relation. So this, I hope this is fine till here. Now there is another relation, empirical formula times N is equal to molecular formula. So students, you just have to follow the formula here. These are just easy questions, right? Empirical formula we found out to be what? C2H4O times N is how much? Times 3 will give you the molecular formula. So how much is the molecular formula? C6H12O3. This is your molecular formula. So see, it's just a scoring question. Okay. So we finished question 12. Coming to question number 13. Okay. So students, this is question number 13. Now in question number 13, there is a reaction of in a blast furnace where iron oxide is reacted with carbon monoxide, giving you iron and carbon dioxide. So this, they have given you directly the reaction. So I'll just write down the reaction. So iron oxide is reacting with carbon monoxide to give you iron and carbon dioxide. Now, in this, X kg of iron is produced. Okay, when 2.32 times 10 raised to 3 kg of iron oxide and 2.8 times 10 raised to 2 kg of carbon monoxide, they react. Okay, and the value of X you have to find out, and the molar mass of iron oxide is given to you. It is 232. To make things easier, carbon monoxide is 28, is given also, and iron is 56. That also is given to you. So knowing all these, we have to find out the value of X. Okay, so these are the informations that's given to you. Okay, iron oxide this is the amount of iron oxide reacting with this amount of carbon monoxide to give you X kg of iron, and the masses are given to you. Okay. Now, over here, we can use the limiting reagent method to find out the amount of iron. That's what we have to find out, right? We have to find out the value of X. So, because they have given you the amount, it's easier, and you have the molar masses also. So, what is the first step to find out the limiting reagent? It is dividing by the molar mass. This is 232. This is 28. Okay, you're finding the number of moles. You're finding the number of moles for both of them. Now, this comes to be 10 raised to 4. This also comes to be 10 raised to 4. Okay, what is the next step? Divide by the least moles. Which one is the, sorry. So both of them comes to 10 raised to 4. Now what is the next step? Divide by balancing numbers. Divide by balancing numbers. What is the balancing number for iron oxide? It's 1. And for carbon monoxide, it is 4. So this comes to be the same, 10 raised to 4. And this one is 2500. Okay. So what is our limiting reagent? Our limiting reagent is Lr is carbon monoxide. So first part of the sum is over. Now, limiting reagent we got. Okay, now I'm keeping the limiting reagent as it is. Now, I'm keeping the equation. Now, in this, we will use carbon monoxide. We will use carbon monoxide and iron, because carbon monoxide is a limiting reagent and we have to find out the mass of iron. Okay, so now we will follow the stoichiometric equation. 4 moles of carbon monoxide is reacting with, what is the balancing number for iron? No number is there, that means it's 1. Sorry, it's 3. Okay, students. So what is the first step during the stoichiometric equation? 4 moles of iron, 4 moles of carbon monoxide is reacting with, we will use a balancing number. What is the balancing number for carbon monoxide? 4. And what is it for iron? 3. So 4 moles of carbon monoxide is reacting with 3 moles of iron. Right. We have the number of moles of carbon monoxide, 10 raised to 4 will react with how much? So when we cross multiply, 4x is equal to 3 times 10 raised to 4. So we get X as 7,500 moles. They did not ask the mass. So this is the number of moles. So from the moles, is it possible to find the mass? If moles is given, you can find out the mass. How? By multiplying. If you know the moles, you can find out the mass. Here they have mentioned X kg. So your sum is not over. Mole time molar mass will give you the mass. You know the number of moles, 7500 times. What is the molar mass given in the question for iron? 56. So when you multiply them, you will get the answer. Okay? As 420,000 and will be in grams, because the question says you have to find out in kg. This is in grams because molar mass is moles per gram. Grams per mole. Sorry, grams per mole. So it's in grams. So this is 420 kg. So this is how you find out. Okay. Coming to the next question, question number 14. In question number 14, you have 2.8 times 10 raised to minus 3 moles of carbon dioxide is left. This is left. After removing how many molecules? 10 raised to 21 molecules are removed. Okay. From x gram mg of the sample, the mass of carbon dioxide taken initially. How much is the initial mass? Okay. Now for that, I have written the information was given in the question. Okay. Now we have to find the initial mass of carbon dioxide. That's the unknown thing. Okay. So we know 1 mole contains Avogadro number of particles 6.02 into 3 10 raised to 23. I think it's given in the question how much you must take. It's given 6.02. So they say they have mentioned in the question 6.02. So take whatever is given in the question. Okay. So 1 mole contains 6.02 times 10 raised to 23. So how much molecules? This many molecules. Okay. This many molecules. So how much of carbon dioxide is removed? 10 raised to 21. So 10 raised to 21 will be how many moles? So first information we already know, 1 mole has 6.02 times 10 raised to 23 molecule. So 10 raised to 21 molecule is how many moles? Okay. So when you solve, you will get the moles of removed carbon dioxide, which is equal to, when you solve this, you get it as 1.66 times 10 raised to minus 3 when you solve this. Okay. Now, I hope till here it is clear. Now, how much is the total moles? Total mole will be how much? Total moles will be total moles of carbon dioxide will be the removed carbon dioxide plus the left one. How much is the removed moles? 1.66 times 10 raised to minus 3. How much is left? It's already given in the question. 2.8 times 10 raised to minus 3. When you add them, you get it as 4.46 times 10 raised to minus 3. This is the total moles of carbon dioxide taken. So total moles of carbon dioxide is what? The removed number of moles and the leftover number of moles of carbon dioxide. So we found out the removed moles of carbon dioxide, and the leftover moles of carbon dioxide is already mentioned in the question. So we found the total moles. Now if you find the total moles, knowing the molar mass of carbon dioxide is 44, can you find the mass? Mass is what? Moles time molar mass. Do we know the moles? We do know the total moles. 4.46 times 10 raised to minus 3. And what is the molar mass? It's 44. and it comes to be equal to, when you solve this, it comes to 4.46 times 10 raised to minus 3 into 44. This comes to 196.24 times 10 raised to minus 3 grams. Okay, so this is your final answer. So first, what did we do? We found the number of moles of the the removed carbon dioxide. Okay, because they have already given you the number of molecules, how many molecules are removed. From there, we found out the moles of removed carbon dioxide, and the moles of the leftover carbon dioxide is given. We added them, we got the total number of moles, and we multiplied with the molar mass. Okay. Okay, students, coming to the 15th question. 81 grams of aluminium is allowed to react with 128 grams of oxygen. Okay, and the mass of aluminium oxide produced, you have to find out, and the molar masses are given. Okay, so these are the information that's given there. I have already written in the whiteboard. So this is the equation. So don't worry about the equations and all. You will gradually know how to write the equations, etc. So with different lessons. Okay. So these are the informations. They have already given the molar masses, and this is the equation. And so you have to find out the mass of aluminium oxide. Okay, this is the unknown factor. So the best way is to do through limiting reagent. Okay, so you already know the steps. The masses of aluminium and oxygen are given. So what is the first step to find out the limiting reagent? To find the number of moles. So moles is what? Mass over molar mass. All this while we have been doing using this formula, mass over molar mass. So 81 over 27. It's given in the question. And the molar mass. And for oxygen, it is 16. So how many oxygen is there? 2 oxygen here. So oxygen, 2 atoms of oxygen is there in the oxygen molecule. So I use 32. Okay. So you will get as 3, and this you will get it as 4. Okay. Now what is the next step? Divide by balancing number. Balancing number over here, it is 4 over oxygen, it is 3. So 3 divided by 4, this is 4 divided by 3. So what have I done? Dividing by the balancing number. Why? To check the number of moles, which will determine which is the limiting reagent. Okay, so this is 0.75 and this is 1.33. So whichever is less in amount, so aluminium is our limiting reagent. So limiting reagent is aluminium. Okay, so till now, I hope till now it is clear. Right. Now, knowing the mass of aluminium, or knowing the number of moles of aluminium or the mass of aluminium, we can find out the mass of aluminium oxide. Okay, so we need the equation now. This is our equation. We don't need oxygen, we need aluminium. We need aluminium and aluminium oxide. So first we check the balancing number. We don't need oxygen now. Okay, so checking the balancing number first. 4 moles of aluminium will react with 2 moles of 4 moles of aluminium will give you 2 moles of aluminium oxide. Now, we already know the number of moles of aluminium. That is, we found out the moles, right? Moles is equal to 81 was given in the question by 27. We already found out the actual reacting moles. So 3 moles of aluminium will produce how much? I take it as X. So 4x is equal to 3 times 2, that is 6, and x is what? 6 by 4. Okay, so this is the moles. How do you find out the mass? Mass is equal to mole time molar mass for aluminum oxide, which is already given to you. How many moles are there? Molar mass is given in the question, right? So you will get this as 153 grams. Okay, so this is how you find out. So if you know the how to do it, the steps, etc., so you can just quickly do it. These steps you don't have to write, just quickly do it because you can save a lot of time. Okay. Now coming to the next question. Question number 16. Density of 3 molar solution, 3 molar sodium chloride solution is, rho is 1.25 grams per milliliter. The molality. So we already studied the relationship between molality and molarity, right? So you can directly use that formula. So molality you need to find out. What's the formula you remember? Molality is equal to 1000, capital M is the molarity, by 1000 D is the density, minus molarity times MB, where MB is the molar mass of the solute, right? So our solute mentioned is, our solute mentioned in question number 16 is sodium chloride. Okay, so here they didn't mention the molar masses, so you have to find out the molar masses. Okay, so sodium is 23, chlorine is 35.5. That comes to molar mass is 58.5. This is the molar mass. Molar mass. Okay. So let's substitute in the formula. 1000 times molarity is 3. 1000 times rho is 1.25 minus molarity is again 3. 58.5. So you just have to substitute in the formula and you get, when you solve it, you get it as 2.79 molality. Okay, so here the direct substitution of the formula. So it is very important, students, to memorize this formula. It becomes very important to memorize this formula. Okay, so you can just save time and quickly you can finish off the sum. Okay, so the next question. Question number 17 is 20 ml of NaOH solution is added to 40 ml of 0.5 molar NaOH and the final concentration of the solution. So you are mixing solute, right? So this is the molarity of what when you are adding solute, or you are adding more solute to the mixture. Okay, so we already know this formula. So 20 ml so students, question number 17, 20 ml of 2 molar NaOH solution is added to 400 ml of 0.5 molar NaOH. So you are mixing. So final concentration. Concentration means molarity. Okay, the final molarity they are asking. So this is the molarity of mixtures. We have already done, we know the formula of molarity of mixtures, right? How to find it. So the formula concentration is just in this term, in this question it is molarity because they have given you information about the molarity. So molarity of mixtures equal to M1V1 plus M2V2 over V1 plus V2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. M1 is 2 times 20 plus 400 times 0.5 over 400 plus 20. 40 plus 200 divided by 420. This comes to 0.571. Okay, but in the question they have asked in terms of 10 raised to minus 2. Okay, so in terms of 10 raised to minus 2, it is 557.1. Okay, see, I'll just share it once again, share the question once again. The final concentration of the solution in terms of 10 raised to minus 2. Okay, so that is why, otherwise we got the correct answer, but we got the correct answer 0.571, but we have to express in terms of 10 raised to minus 2. So just playing with the decimals, that's it. Okay. So students, coming to the next question, question number 18. Okay, now in this question, in question number 18, ten ml of gaseous hydrocarbon, 10 ml of gaseous hydrocarbon. Hydrocarbon, you will learn later that it is made up of substance made up of carbon and hydrogen. Hydrocarbon, hydrogen and carbon. Okay, on combustion. Okay, on combustion means you're burning it with oxygen. Will give, always whenever hydrocarbon undergoes combustion, it gives you carbon dioxide and water. Okay, and how much of hydrocarbon they have taken? 10 ml. And how much of carbon dioxide is given off? 40 ml. And water vapor is 50 ml. Okay, and the total number of carbon and hydrogen. So carbon atom how much and hydrogen atom how much? That's what you have to find out. Right, now. So the information that's given, I have already written. Okay, now we don't know the number of carbon atom in this is hydrocarbon made up of carbon and hydrogen. Okay, so we don't know how many carbon and hydrogen, that's the question. So it is difficult to balance, but let's assume that there is X carbon atom and Y hydrogen atom in the compound. So CXHY. Okay, let's assume that X is carbon and Y is X. There are X number of carbon atom and Y number of hydrogen atom. So if you are doing like, if you are writing X and Y, you have to balance it. So CX means there are X carbon atoms. So I write this as X. Balance it by X. Okay. Now hydrogen, over here, there are Y hydrogen atoms. Hydrogen in the reactant side, there is Y hydrogen atom. There is one Y. Okay. Here in the steam, in water vapor, how many hydrogens are there? 2. Right? So if I write Y by 2, yes. So if I write here, Y by 2, what does it mean? Y by 2 times 2 hydrogen atoms will give you Y. So for hydrogen. So is the number of hydrogen atom in the reactant and product equal now? So what did I do? Here in the reactant side, there is one Y. Okay. In the product side also, we have to balance it and make it into one Y. Because there are already how many hydrogen atoms? 2 hydrogen atoms. So how can I make it into one Y? I have to multiply the 2 hydrogen atom with Y by 2 so that I get what? Y. So that I get Y. This is what I have done. Why? So that I can make the number of hydrogen atom in the reactant and product the same. Now, after this, oxygen. For oxygen also, how many oxygen atoms are there in the product side? Let's check. 2x and y by 2. Yes. So these many oxygen atoms are there. But in the reactant side, how many oxygen atoms are there? 2. All right. By this 2 so that it comes to x plus y by 4. When I now, students, this oxygen is always in excess. Okay. Now you need to find out the number of atoms of carbon and hydrogen. Okay. Now over here, we will not talk about oxygen because oxygen is something that is in excess. So what is our limiting reagent? Our limiting reagent is CXHY, because always whenever there is combustion giving you carbon dioxide and water, that means oxygen is always in excess. Okay. Now, so we ignore this. We will not use this. Okay. Now coming to, so we will use we will be using CXHY. Okay. Now, looking at the balancing number, I'll rewrite the equation once again. CXHY plus x by y by 4 O2, giving you XCO2 plus y by 2 H2O. Okay. Now, looking at the balancing numbers. What is the balancing number for CXHY? It is 1, right? So 1 mole of CXHY is giving you X moles of carbon dioxide, right? Or we talk in terms of volume. What is the balancing number? CXHY. And here the balancing number of is X. Okay. So let's use the Gay-Lussac's law of volume. So 1 volume of CXHX is giving you X volume of carbon dioxide. Here they have already given you in the question, they are using 10 ml of CXHX. So 10 volume will give you how much? 10x volume of carbon dioxide. 10x volume of carbon dioxide is equivalent to how much volume of carbon dioxide they have taken initially, or in the question 40 ml. So can we find out x from here? It is equal to 4. Okay. Similarly, I'm rubbing this part. Similarly, 1 mole of or 1 volume of CXHX gives you y by 2 volume of water or steam. So 10 volume will give you how much? Y by 2 times 10. And this y by 2 by 10 is equivalent to how much? How much they have given you initially? 50 ml. So y equal to 50 times 2 by 10. So y equal to 10. So CXHY. X is 4, Y is 10. This is our hydrocarbon. Okay, so this is how you find out. So we are using Gay-Lussac's law over here. So the 19th question, if you look at the 19th question, .05 centimeter thick coating of silver is deposited on a plate with area 0.05 meter square. The number of silver atoms deposited. So number of silver atoms. They have asked, and the density they have given as 7.9 grams per centimeter cube. Okay. So from this question, you have to tell the number of silver atoms. Okay. Now the informations that they have given, I have already noted it. Okay. Now, density is being given. Now the thickness of silver is given. Ag stands for silver. Right. Now, if thickness is given and the area is given, can we find out the volume? We can find out the volume. Volume is what? Thickness times area, right? So 0.05. We will try to maintain everything in centimeter because the density is centimeter cube. Okay. So thickness is given in centimeter already, 0.05 times area is 0.05 meter square. So I'm making it into centimeter square by multiplying it with 10 raised to 4. So meter square, so 100 into 100, so 10 raised to 4 centimeter square, and this is centimeter. So this is our volume, so centimeter cube. Okay, now if I know the volume, can I know the mass? Density type, rho is density, okay, write D. Density times volume. Density is mentioned, 7.9 grams per centimeter cube times volume. Volume is what? 0.05 times 0.05 into 10 raised to 4 centimeter cube. Okay, so this gives you 25 times 7.9. Okay, I'm keeping it as it is. Okay, this is 0.05 and 0.05. So the 10 raised to 4 gets cancelled with this. Okay, so this is our mass. I'm keeping it as it is. Okay, this is grams. Okay, now you have to find out the number of what? The number of particles. Okay, from mass, if you know the mass and you know the molar mass of silver is 107. Okay, it's given in the question. Can you find the moles? Moles is equal to what? Mass over molar mass, which is 108. Sorry, 108. 108. This is the moles. Okay. Now, students, you already know the relation to find out the number of particles. Number of particles you can find out by multiplying the number of moles with Avogadro number. Okay, so do we have the number of moles in our hand? Do we know the Avogadro number? So students, do we know the number of moles? So you can use moles over moles time Avogadro number to find the number of particles. So this is our moles time 6.023 times 10 raised to 23. It will give you the number of particles. Okay, and it comes to around 11.01 times 10 raised to 23. Okay, this is our question. So coming to the next question, question number 20. In question number 20, you have the number of moles of methane required to produce 22 grams of carbon dioxide after combustion. So the number of moles of methane is CH4, is x times 10 raised to minus 2. Okay. And you need to find the value of x. So this is yet another combustion reaction. Students, you can see methane, the formula is CH4. It is made up of only carbon and hydrogen. Okay. So it is a hydrocarbon, CH4. So it's a hydrocarbon made up of only carbon and hydrogen. So when you are treating methane with oxygen, always whenever the combustion of hydrocarbon takes place in excess of oxygen, it gives you carbon dioxide and water. Okay, so we need to balance it. Okay, so they have given you the mass of carbon dioxide. It is 22. Now, from there you need to find the moles of, or you need to find the moles of methane. This X is the unknown thing. That's what you need to find out. Okay. Now, we will go with the stoichiometric equation. We are asked about methane. We are given information about carbon dioxide. Okay. Carbon is 12. Oxygen is 16. So carbon dioxide, the molar mass is 12. The molar mass of carbon dioxide. Carbon is 12 plus 16 times 2, which is equal to 44. Okay. So moles of carbon dioxide, mass is 22, mass over molar mass, right? 22 over 44, which is equal to 1 by 2.5. Okay. Right. One by 2.5. Now, the balancing number for methane, if no number is there, that's equal to 1. Here also it's 1. So 1 mole of methane is reacting with 1 mole of carbon dioxide. Okay. Now, we cannot go with the limiting reagent because they have not given you the mass of the reactants. Okay. So we have to use the stoichiometric equation. So 1 mole is giving you 1 mole. So how many moles is how many moles of methane, that is x times 10 raised to minus 2 moles of methane, will give you 0.5 moles of carbon dioxide, because we already found out the number of moles of carbon dioxide. So 1 mole of methane is giving you 1 mole of carbon dioxide. So 0.5 moles of carbon dioxide is obtained from how many moles of methane? So we can do the cross multiplication. So 0.5 is equal to x times 10 raised to minus 2. So x is equal to 0.5 times 100, which is equal to 5 moles. 50 moles, sorry. So the value of x is 50. Value of x is 50. So we solve this using stoichiometric equation. Now students, the next one, question number 21. the molarity of 1 liter orthophosphoric acid having 70% purity by weight, and specific gravity is nothing but density. Okay, so you can take this as density, gram per centimeter cube. Okay, so you need to find the molarity. Okay, now in this 1 liter, the volume is given to you 1 liter. Okay, so you need to find the molarity, and the molar mass is given. Molar mass is 98 grams per mole. So these are the information that's given. Okay, so I've already written down the information that's given. So 70% purity, and specific gravity is nothing but density. Molar mass is given. Okay. Now, if I have the volume, that is 1 liter, if I know the density, can I find out the mass? Mass is equal to volume time density. So 1 time 1.54. Okay. So here I need to make a small change. The density is given in grams per centimeter cube, right? So 1 liter is equal to 1000 milliliter or centimeter cube. So I will change this liter into milliliters. That means 1000 times density. I'll just keep, because this is in centimeter cube. The density is in centimeter cube. Okay. So I get the answer as 1540. 1540. Right. This is the mass. This is in grams. Right. Now, if I know the mass, how much is the percentage purity of that acid? So percentage purity is 70%. So 70 by 100 by times 1540 will give you what? The exact amount of the acid, right? So exact mass of the acid, exact purity of that acid, right? So the acid is 70% pure. Okay, so using this formula, I can get the mass of the acid that is pure, right? So if I use this formula, I'm getting 1078 grams. So although I have 1540 grams of the acid, how much is pure? 1078 grams. So I'll be using this mass. Okay, so our actual mass is actual mass is 1078. Why? Because although we have 1540 grams of the acid, only 70% is pure. So we need the pure acid. Now, in this, what we need to find out? The molarity. Molarity, you already know the formula. Molarity is what? Number of moles per liter, volume in liters. We need to find the volume is already in liters, that is 1 liter. Okay, now number of moles, how to find out? Mass over the molar mass is already given, 98 by, this is grams per mole, by 1 liter. So how much is the answer? 11, capital M. So 11 is the molarity. Okay. So whenever you find the mass, and if the purity is given, you have to check the purity also, how much of the pure mass you are taking. Okay. Okay, students. Now coming to the next question. Question number 22. In question number 22, five moles of barium chloride is reacting with sodium phosphate to give barium phosphate and you will also get sodium chloride. So you need to find, you have been given 2 moles of sodium phosphate also. So you need to find the number of moles of barium phosphate. Okay, so this is the unknown thing that you need to find out. Okay, so already written the equation. Okay, don't worry about the equations, you will be learning it. Sodium chloride. Okay, so here you have barium phosphate. 3 barium is here, 3, and you have phosphate is 2. I write here 2. So that makes sodium how much? Sodium is 6. 6 sodium chloride. I'm writing it here. Okay, 6 sodium chloride. Okay. Okay, 6 sodium chloride. So oxygen is 2 times 8. 8. So it's balanced. Chlorine is 6 on the left hand side, 6 on the right hand side. 6 sodium atom on both sides. Okay, so it seems to be balanced. So you need to find the number of moles of barium phosphate. Okay, the one of the products, that is barium phosphate, Ba3PO42. That's barium phosphate. Okay, now you have been given the number of moles of both the reactants. If you know the number of moles or even the mass of both the reactants, you can go by limiting reagent method. So in this case, they have made your task a bit easier by giving you directly the number of moles. So 5 moles of barium chloride is reacting with 2 moles of sodium phosphate. Okay. Now, if you know the number of moles, okay, what for limiting reagent, what is the next step? Remember the steps when you were given the masses, you find the number of moles, and that number of moles you divide by what? Divide by the balancing number, right? Divide by balancing number. In this case, the balancing number is 3. In this case, the balancing number is 2. So we divide by, so you have skipped one step because they have given you the moles directly. So 5 by 3, 2 by 2. So this is 1.66 something, and this is 1. So what is our limiting reagent? Clearly, our limiting reagent is sodium phosphate. So now we will be using sodium phosphate and barium phosphate because they have given you the information. You know the limiting reagent of sodium phosphate, and you can find out the mass of barium phosphate, Ba3PO42. Okay, so I don't need these steps now. I just know that my limiting reagent is sodium phosphate. Okay, so I'll just write it here. Limiting reagent is sodium phosphate. And how many moles are there? 2 moles. That's given in the question. Okay, so as usual, we will go by the stoichiometric equation. So looking at the balancing number, the balancing number here is 2. 2 moles of sodium phosphate is reacting to give 1 mole of barium phosphate. So 2 moles of the limiting reagent moles, 2 moles of sodium phosphate will give you how much? X moles of barium phosphate. You cross multiply and you get X equal to 1. This is your answer. They have asked you for what? The number of moles. You don't have to make it into mass because they have asked you moles only. Okay, so students, first we find out the number of moles because instead of mass, they have given you the moles directly. So they have made your work a bit easier. And by the steps that we usually follow, dividing by the balancing number and all, we came to know that our limiting reagent is sodium phosphate. Then we use this sodium phosphate to find out the number of moles of barium phosphate using stoichiometric equation. Okay. Coming to the 22nd question. 22nd we finished, 23rd. Okay. The number of molecules in 23rd question. The number of molecules and moles in. So two things they have asked. The number of molecules and also the number of moles. Two things they have asked. In 2.8375 liters of oxygen at STP. They have mentioned STP. So from this one information given, they have asked you two things. Okay. Now, students, here, we already know you can find out the number of moles, volume given by molar volume. It is nothing but 22.4. This should be at STP. Clearly, it is mentioned STP. So it's a direct question. So volume given is what? 2.8375 over 22.4. So how much is the number of moles? 0.126 mole. So one part of the question is done. Okay. Now, if you know the moles, you know the number of molecules. How do you find the number of molecules? The number of molecule equal to mole time Avogadro number. 0.126 times 6.023 times 10 raised to 23, which comes to 7.5 into 10 raised to 22 molecules. Okay. So second part of our question is also over. Okay. So this was just direct application of the formula, but you be careful of the calculation. Okay, students. Now coming to question number 24. In question number 24, a solution is prepared by adding 2 grams of X to 1 mole of water. Okay. And the mass percentage of X in solution is the mass percentage. They have asked the mass percentage. Okay. And the mass percentage. So mass percentage you already know that you find out the mass percentage by what? Mass of element X by, so mass percentage is equal to what? Mass of element X by total mass times 100. Right? Now, we know the mass of X, we know. They are given directly as 2 grams. Right. In order to know the mass of the whole solution, In order to know the mass of the whole solution, we need to know the mass of the water. Mass of water. We don't know. But they have given you that it is 1 mole of water. Now, I already told you students during the lesson, 1 mole of any substance weighs equal to the molar mass in grams. So, here the molar mass of water is hydrogen is 1 times 2 plus 16. It's equal to 18 grams. Okay. So students, this was discussed during the lesson that 1 mole of any substance weighs equal to the molar mass in grams. So the weight of water is 18 grams. Okay. So now the mass of water we got 18 grams. Okay. So what is the total mass of the solution? Total mass is solute plus solvent. What is the solute X? Solute X plus solvent water. Solute X plus solvent water. How much is solute X? 2 grams. How much is solvent water? 18. This comes to 20 grams. So, students, do we have to find out the mass percentage? Do we have the mass of solute X in our hand? We have the mass of solute X, which is equal to 2 grams. What is the total mass of the solution? 20 times 100. So see, instead of giving the masses directly, you have to find out some masses and you have to find out the mass percentage. Okay, only be familiar with the formula and also to substitute the correct values. Okay, so it was a simple question, but be careful with the calculations. Okay, now the 25th question is okay, students, we are left with the 25th question. Okay, so if you look at the 25th question, it says that the metal chloride contains 55% of chlorine. Okay, and another information is given, 100 ml of vapors of the metal chloride. Metal chloride weighs at STP 0.57 grams. Okay, at STP. So this is the information given, and the molecular formula of the metal chloride you have to find out. Okay, so sharing the screen, sharing the whiteboard. These are the informations that's given to you. So I just noted down the information. Okay, now over here the concept that you have to use is percentage composition. Percentage composition. What's the formula for percentage composition? It's given by mass of element by mass of compound or mass of the molecule times 100. That's the formula that we'd be using. Okay. So in this particular case or in this particular sum, we can find out the number of moles of the compound. We can find the number of moles N of the compound. For 100 ml, it contains 0.57 grams of the compound, right? Or metal chloride, MCl. Okay, I don't know the formula, so I'm just written metal chloride, MCl, short form. Okay, so it is given by 0.57 by capital M. Capital M is the molar mass of metal chloride is M. Okay. This is equation number 1. And we will make one more equation. Number of moles is also equal to volume at STP by molar volume, which is 22.4, right? So number of moles equal to volume given. They have given the volume in milliliters. So we have to make it into liters by dividing by 10 raised to minus 3 by what is the molar volume? 22.4. We will make this as equation 2. Now both equation 1 and 2 are number of moles. So we can equate 1 and 2, right? So I'll use another color. 0.57 by M, which is the molar mass of the metal chloride, is equal to 100 times 10 raised to minus 3 by 22.4. When you solve this, M comes to 127.68 grams per mole. Okay, so this is the molar mass of the molar mass of the compound. Okay, now from here this part I don't need now. We found out the molar mass of the compound. Now coming to the concept, we know the percentage composition of chlorine is 55%. Okay, so 55% equal to mass of the element is the molar mass of chlorine that's given in the question is 35.5. How many atoms are there? We don't know. So I multiply with X. Okay. X is the number of atoms. That's how we find the molar mass. By mass of the compound. Molar mass of the compound is 127.68. We found out times 100. Okay. So this part I don't need now. So I'm using this concept. Okay. So molar mass comes to, or the number of atoms comes to 2. So the formula of metal chloride is MCl2. Okay, so this is how we find out the number of atoms. Okay, students, we solved some questions of past paper questions of JEE and NEET. Okay, that's all for today. Thank you. Have a nice day.